Imagine standing on a beach at dusk, the air cool and still. Your feet sink into rust-red sand, softer than you'd expect, as gentle waves lap at your ankles. The water stretches far, dark and shimmering, meeting a horizon painted in fading pinks and purples. For a moment it feels like home, like an evening by the ocean on Earth. Then you look up. Two moons hang in the twilight sky, small and strange, their faint glow a reminder you're not on Earth at all. You're on Mars, billions of years ago, when this dry, barren world was alive with water. Buried in the soil, it uncovered clues pointing to vast ancient oceans that stretched across the planet 3.6 billion years ago. These weren't just puddles or fleeting streams. They were shores, alive with the possibility of life, where waves rolled and tides rose under the pull of two moons. This discovery isn't just a line in a science book. It's a window into a Mars we've lost, a planet that might have hosted life before it turned to the frozen desert we see today. And it's a mirror to our own world, where water covers 70% of the surface and makes up 60% of who we are. Water is life's essence, scarce in the cosmos, yet here it was on Mars, whispering of a past we're only beginning to understand. For decades, we've wondered about water on Mars. Some said oceans were a myth, pieced together from blurry satellite images or wishful thinking. Scientists argued, pointing to indirect clues: riverbeds carved in stone, polar ice as vast as a continent. Others shook their heads, saying the data was too vague, too open to doubt. But now, we have something new. Evidence from the ground itself, not just from above. A rover rolled across a place called Utopia Planitia, a massive basin wider than anything on Earth, and found proof that silences the skeptics. This isn't just about rocks or radar signals. It's about rediscovering a world that might have been a home for life, a place where the building blocks of existence could have taken root. Today, we'll uncover the mission that changed everything, the secrets it pulled from the Martian soil, and the questions it leaves us with, chasing answers in the stars. Let's dive in. Water is everything. It covers most of our planet and runs through our veins. Without it, life as we know it wouldn't exist. Yet in the vastness of our solar system, water is a rare treasure, scattered in frozen traces or hidden deep. On Mars, though, we now know water was once abundant, flowing as far back as 4.45 billion years ago. Tiny crystals in a meteorite that crashed to Earth told us this. They could only form in hot, water-rich pools, like those bubbling in some ancient Martian spring. Even the dust on Mars holds clues, a mineral called perhydrite, born only where water touches rock. These are whispers of a wetter past, a time when Mars wasn't the dry wasteland we see now. Rivers once snaked across the Martian surface, cutting paths we can still trace. Polar ice, sprawling as wide as the United States, clings to the planet's edges, maybe hiding traces of ancient life frozen deep within. Now, let's step into the heart of this cosmic journey. On July 23, 2020, a spacecraft pierced the void, launching from Earth on a 202-day trek to Mars. It wasn't just metal and circuits. It carried humanity's hunger to know, to touch the secrets of a world long gone. Inside its hull were an orbiter, a lander, and a rover, each built to peel back the layers of the red planet's mysteries. Their destination? Utopia. Planitia, a vast basin wider than any crater in our solar system, a place whispered to be the floor of an ancient ocean. This wasn't a random choice. Satellite maps had hinted at something extraordinary here, and now it was time to dig deeper, literally, into Mars's past. The mission had three bold goals: to map the geology of this suspected ocean bed, to track its climate and magnetic whispers, and to hunt for signs that life could have once thrived there. This was no small dream. It was a quest to rewrite what we believe about Mars, and maybe about life itself. By February 10, 2021, the spacecraft reached Mars, slipping into orbit like a dancer finding her mark. For 3 months, controllers tested every system, nudging the orbit from equatorial to polar, preparing for the main act. On May 14th, the lander kissed the Martian soil, and a week later, the rover rolled out. A 240-kilogram marvel, bristling with tools to probe a world frozen in time. This was a historic moment, marking only the second time a nation had set a rover on Mars's dusty plains. The rover landed in Utopia Planitia, a place steeped in history. Nearly 50 years ago, NASA's Viking missions touched down here, but a 2016 discovery reignited our curiosity. Beneath this basin lies a frozen sea holding as much water as Lake Superior, 12,100 cubic kilometers, a staggering 10 to the 16th power liters locked in ice. If Mars had oceans, this was the place to find their echoes. The rover wasn't just a wanderer, it was a scientist, armed with 13 instruments split into 4 kinds of magic. First, radars that could peer 100 meters beneath the surface, like eyes seeing through time to map hidden structure. Then, spectrometers, both laser and infrared, to taste the soil and rocks, revealing their chemical stories. Cameras, some on the orbiter, some on the rover, captured the planet's face, mapping its curves and guiding the rover's path. And monitors, delicate and precise, tracked the magnetic field, the radiation, the whispers of wind, temperature, and pressure, even the faint sound of Mars itself. There was something else, too. A tiny camera, detachable, that snapped self-portraits of the rover against the endless red. Those images, sent across millions of kilometers, weren't just data. They were a lonely explorer's postcards, proof of a daring leap into the unknown. This mission wasn't just science. It was a nation proving it could stand alone in the stars, charting a path for future quests, maybe even humans walking on Mars by 2033. But what did this rover find that others missed? Let's walk with it through Utopia Planitia, where the ground holds secrets older than Earth's oldest mountains. The rover's radar sent radio waves deep into the soil, and when they hit a boundary, say, where fine sediment meets coarser sand, they bounced back, painting a picture of what lies below. What the team saw stopped them cold. 76 reflectors, all sloping the same way, angled between 6 and 20 degrees, stretching 1.3 kilometers toward the lowlands, buried 10 to 35 meters deep. This wasn't random. On Earth, we know these patterns. Sloping layers along coastlines where waves and tides shape the shore. Think of a beach on our planet, where sand settles between high and low tides, forming gentle slopes for fine grains or steeper ones for cobbles. These Martian slopes matched Earth's buried beaches, like those in the Bay of Bengal, so perfectly it felt like fate. One scientist said it plainly. These structures scream of waves, of rivers feeding sediment, of a shoreline alive for ages. Could this be it? The undeniable proof of an ancient Martian ocean? The team tested other ideas. Could these be sand dunes or lava flows? No, those would scatter slopes in all directions, chaotic and varied. But these reflectors pointed one way, steady and sure, like a coastline kissed by tides. Mars's sun and its moon, Phobos, tugging at the planet's gravity, could have stirred those tides, just as our moon moves Earth's seas. This was no fleeting puddle. This was a dynamic shore, shaped by wind and water 3.6 billion years ago. The rover's discovery wasn't just a signal in the dirt. It was a shout from a lost world. A world where waves crashed and life might have begun. Suddenly, Mars felt closer. Not just a red dot in the sky, but a place that once pulsed with possibility. Its shores a cradle for something we can only imagine. But here's where the story twists. For decades, scientists have wrestled with a mystery that clouds this vision of a watery Mars. The clues are clear: riverbeds etched in stone, ice locked in polar caps, and now these buried shorelines whispering of ancient oceans. Yet something doesn't add up. Billions of years ago, when Mars supposedly cradled these seas, our sun was a faint shadow of itself, 25% dimmer than today. Too weak to warm Mars above freezing, too feeble to melt ice into rivers or oceans. This is the faint young sun paradox, a puzzle that haunts every discovery about Mars's past. If the sun couldn't provide the heat, where did the warmth for liquid water come from? This question isn't just a scientific snag, it's a tug at our hearts, a reminder that Mars's story is as elusive as it is enchanting. The rover's findings, those sloping layers in Utopia Planitia, demand we face this paradox head-on, forcing us to rethink what we believe about a planet that might have once been alive. Scientists have spun 3 ideas to unravel this mystery, each a thread in a tapestry of wonder and doubt. First, picture a Mars warm and wet, its skies thick with greenhouse gases like carbon dioxide and water vapor, maybe laced with methane or ammonia. This heavy blanket could have trapped enough heat to keep oceans liquid for millions of years, letting rain fall, rivers flow, and shores thrive. But here's the catch. Our models say those gases alone can't muster the warmth needed, and others, like methane, fade too fast to hold the heat long-term. Another idea paints Mars as a world of fleeting summers. Massive volcanoes or asteroid strikes could have erupted, spewing heat and gases, melting ice into rivers and lakes for brief, glorious spells. These bursts might explain the erosion we see, but were they frequent enough to carve all those valleys to fill vast basins with water? We don't know. Then there's the third path. Mars is a frozen giant, cloaked in snow and ice, with rare thaws sparked by shifts in its orbit or sudden bursts of heat. This fits the signs of glaciers and fleeting streams. But what melted the ice often enough to sculpt the planet we see? Each idea holds a piece of truth, yet none completes the puzzle, leaving us aching for answers. The rover that found those ancient shores, that 240-kilogram explorer, was only meant to roam for 93 Earth days. But it defied the odds, rolling through Utopia Planitia for 358 days, until May 20th, 2022, when dust piled too thick on its panels, and it fell silent. We hoped it would wake in December when sunlight might clear the dust, but it stayed quiet, its mission done. Yet its legacy burns bright. Those sloping reflectors, proof of a coastline 3.6 billion years old, have changed the game. They don't just confirm water, they point to a dynamic world where waves crashed, tides rose, and life might have stirred. But the story doesn't end here. The water that once flowed, where did it go? Did it sink deep into the planet, freeze in hidden reservoirs, or vanish into the thin Martian air? What turned a world of oceans into the cold desert we know? And if life bloomed along those shores, could its traces still lie buried, waiting for us to find? These questions pull us forward, urging us to return to Mars. Plans for a mission to bring back Martian soil, once set for the 2030s, now teeter on the edge, pushed to 2040, or beyond by budget shadows. If it happens, those samples could unlock the planet's ancient geology, maybe settling the debate over its watery past. But even without them, the rover's discovery has shifted our gaze. Mars isn't just a dead world, it's a lost one, a place where life's spark might have flickered. Could Earth face a similar fate, its oceans drying under a changing sky? Or could Martian microbes, or their fossils, still hide beneath the surface waiting for our next step? This isn't just about science, it's about who we are, where we came from, and whether we're alone. The red planet holds secrets that call to us, daring us to keep searching, to keep dreaming of shores we'll never walk but can't stop imagining. What's out there, waiting in the dust? Only time and another bold journey will tell.